So anyway, with that, why don't I turn it over to you, and I'll be your slide jockey. So just tell me when to hit the next slide.
Thanks a bunch, Jeff. I appreciate it, and thanks for having me. As Jeff said, I am and now talking to people all day about smart home systems, smart energy management, and energy automation. And that just gets me out of bed every day. I love it. I'm very excited about smart energy management, and I'm grateful to be able to share it. On the next slide, we're going to talk first about predictions about energy storage. And the reason we're talking about that, can everybody hear me?
Yes.
Okay, great. We're going to be talking about that because it is a big deal. Right now, energy storage is predicted to grow between 2017 and 2022, just in the US. A 900% growth is predicted. And according to marketandmarkets.com, global battery energy storage systems are going to grow from 2.9 billion in the world to $12.1 billion in 2025. And who's investing in these types of batteries? Well, we've got Tesla, we've got Shell Oil, we've got big companies, and they are helping us move from fossil fuels to renewable energy. And I'm super psyched to be able to bring this to you. So the next slide is our agenda. And we're going to talk a little bit about an overview of smart energy technology for the home, how it's helping architects, developers, and designers, builders to design homes, multi-dwelling units, and even communities of renewable energy for the future. So in the next slide, the agenda is covering what is smart energy management technology, why we design with energy storage, residential energy standards, applications of energy storage, how you can select an energy storage system for your homeowner, implementing energy storage system design into your thoughts and plans for the future, and then we'll conclude this. The next slide is, it's just housekeeping. While we are not an AIA provider, this is an AIA course, so you would get 1 credit. You are eligible if you complete the course, which is just staying through to the end. It is a self-reported course, so you report it through AIA, and certificates will be provided by us and Boca Tech and Automation. The next slide is, what is smart energy? Can everybody see the slides? Because I can't.
You can't see the slides?
I cannot.
No wonder. I think I'm a little out of sync, but we're on the slide that says, what is smart energy management technology? So just say next slide, and then I'll hit the next button.
Right. Okay. So we are going to talk about what smart energy management is. The next slide will show us a basic grid infrastructure, and that shows us the current grid design. It's important to understand how the home gets its power. First, it's generated at that power plant. You can see A on the slide shows the power plant. The primary power plant produces most of the needed power using nuclear power, coal, natural gas, and even solar. These power plants can't ramp up quickly, though, if more power is demanded. So they create peaker power plants. They add a power plant on to produce power when high demand, like at night or early in the morning when those peak times of demand come in. Often these are coal-fired dirty power, and that's not great for your systems at home. So once the power is generated at that power plant, it's transmitted through a distribution network to be there when you turn the light switch on in your home. This grid infrastructure has been around since 1882, nearly 140 years. And more than 70% of the grid's transmission lines and transformers are older than 25 years. The average power plant is over 34 years old. So this grid structure is not a sustainable plan for us. With this grid system, energy has to be consumed when it's produced. There's no ability to save energy for later. So we'll go to the next slide. And we'll talk about a daily consumption cycle when we add solar. So the blue on this chart shows that the energy drawn from the grid. In a typical day, you wake up in the morning, you take a shower with hot water, you put the coffee on, you're maybe watching the news, you're unplugging your electric vehicle if you're Jeff or me or somebody else like us. And then typically, not in a pandemic, you wouldn't be home all during the day. So you've got that dip in demand. When you come back at night, you're watching some news, you're making dinner, you're putting the laundry in, and things like that. Now we're going to look at that yellow part. If we add solar to the typical home, the yellow shows the photovoltaic solar production, the PV production. Smart energy management technology at the very basic level means we collect that excess energy generated by the sun during the day, or even excess from the grid, and we store it for use later at night or during a power outage. We're storing that energy in a battery and choosing how to use that energy later. In the next slide, we talk about why we would design with energy storage. And in the next slide, it shows number one, the first reason we might choose to design with energy storage is to move away from fossil fuels to renewable energy. I know the homeowners that we work with are already talking about clean and healthy living. That's a real subject about wellness and health. And homeowners are asking for energy independence and energy stability. In California, with the recent fires, floods in Texas, hurricanes in Puerto Rico, Louisiana, Texas, and Florida, energy isn't a given. We are not given stable energy all the time. And if you're like me in Flicker Flash, Florida, we have a real intermittent power issue in Florida. So in some areas of the country, the cost of solar is about the same with grid energy. In some cases, solar is actually lower, like in California or Utah. And politics aside, we see globally that aggressive climate goals, strong policy commitments will require more renewable energy resources. So right now, in 2020, there's still a federal tax credit. Same thing next year. This year, if you put solar plus a storage battery on a project, you get a 26% tax credit on that investment. In 2021, the tax credit is reduced to 22%, but it's still a pretty decent tax credit. There are also utilities offering programs, and with renewable energy and storage, you can meet energy efficiency building standards. Ultimately, the goal is healthy, sustainable living, and we all want to leave something behind for future generations. So the choices we make today can set the stage for years to come. And we'll discuss that in a few slides. So the next slide shows us that renewable energy is solving a problem. But just putting solar on a roof is not going to help existing grid infrastructure. In fact, it can hurt it. Here's how. Utilities are challenged by meeting the current demand for energy. In addition, right now, there's a huge influx of people moving to Florida from cities up north. It's putting more of a strain on our utilities and grid. Here's a good example. The city of South Miami created a new building standard requiring new homes to have solar added as an electricity source. But if residents are producing more energy in the middle of the day, right, then there may not be enough loads to accept that energy that they're producing. So because they are connected to the grid, if this situation causes strain on the transmission and distribution of that energy, as a result, that clean energy that those good-hearted people in South Miami are producing, it could be just dumped into the ground or sold to nearby states. So designing with energy management and energy automation in mind will help utilities by using a distributed network of energy storage systems. And we'll talk a little bit more about VPPs and that kind of thing. So we're reducing the grid strain, using clean energy when it's needed most in peak periods, reducing the need for dirty peaker plants like coal plants or nuclear plants, and we're enabling customers to use solar power at night. Are you guys hearing me still? Is everything good?
All good, Deb.
All right. Next slide, please. It shows the mismatched supply and demand. We have a duck curve here. What it's doing is we're seeing on one particular day over several years, it's March 31st in California, they show the difference of power supply and demand. They're showing that in 2012, it was a little bit more even, and it started getting a little bit more uneven each year. And in 2020, that dip, which they call the duck belly dip, in the daytime is your solar production, but it actually exceeds the requirement, the need. And so the head of the duck represents the spike in demand in the evening hours. It requires the utility to ramp up to 13,000 megawatts of power in just 3 hours. So putting solar on the roof doesn't solve the problem. It actually adds a challenge to the grid. Let's go to the next slide. Designing with energy storage prevents. So we can prevent the oversupply of power by reducing the use of dirty peaker plants, harnessing that local power and to meet that demand spike. It could prevent non-coincidental peaks, which means the peaks in demand like in the morning and at night, different times in the day. Energy storage, just storing solar power into your battery can also prevent overall grid stress from voltage fluctuation or loss and inefficiency. Let's look at that chart on the left. If too much demand and too little supply, the voltage frequency decreases. And that turbine that's producing the power is spinning too slow. That can cause electronics in your home to experience flickering and blips. That actually damages your electronics and reduces the life expectancy of your electronics. The same happens if there's too little demand, causing too much supply. The transmission wires can actually overheat, expand, and sag, causing rolling blackouts or brownouts at home. Localized energy storage, meaning in my house or in the community with solar, can provide a cleaner power to make those devices in your home run longer and better and keep the power on for homeowners. And with energy, we're going to go to the right part of that slide now. Homeowners, we can help homeowners by preventing inefficient use of solar energy, damage to sensitive electronics, loss of solar production during a power outage. I'm just going to explain that real quick because a lot of people don't understand that if you're producing solar power and there's an outage on the grid, that means you can't use your solar power, because if there's a lineman trying to fix that, they turn that off. It's a law to keep them safe, of course. But the only way you can use that power in an outage is if you have storage. So that, I just want to clarify that. If you've been in Florida long, you may have experienced rolling blackouts and brownouts. I certainly did in Wellington for years, but it's much better here. Mandatory shutdowns too. So now we understand the grid requires a resource mix of different types of power that can react quickly to rapid changes. Energy storage and management is how we're going to solve that problem, and we're going to offer energy resiliency. Let's go to that next slide. We're going to show that designing with energy storage enables us to decentralize, decarbonize, and digitize the grid. Instead of that antiquated grid that we saw, we're going to move forward and we're going to create distributed energy resources to provide redundancy, flexibility by being localized at the point of consumption. Meaning I'm going to produce my energy and I'm going to use my energy. Less reliability on the grid, energy independence during outages. We're going to reduce the need to use those peaker power plants during high demand periods. And we're going to, energy storage also allows us to create virtual power plants. That virtual power plant is a collection or community of batteries that act as a hive or a group, a community of batteries, and they can actually sell to each other. If I'm using more today than I produce, I can buy for my neighbor, for example, or we can sell it back to the grid. There's a lot of great ways to create this, and we're going to talk about some more later. Let's go to the next slide. We're going to talk about a little bit about local code compliance, because some areas actually require storage because local grid infrastructure is not enough to handle the solar. We can see examples of this in like Aspen, Durango with mountain utilities. There are several different residential energy standards that architects, builders, designers, developers are designing toward. Some of these include the Home Energy Rating System, or HERS, the EPA's Energy Star for Homes, Zero Energy Ready Homes, Zero Net Energy, ZNE, the Leadership in Energy and Efficient Design, that's probably the most well-known, LEED certification, the Green Build Standard certification, and the Passive House. I have, at the very end, created a little a slide to give you all of those places to visit, some more resources to find out more about that. Are we still connected? All right.
All good.
All right. Residential energy standards. Now we're going to delve into some of those standards real quick. We're going to go through these quickly because it's already 11:20. So the next slide shows energy rating systems for residential buildings. Let's see. So a building with zero net energy consumption means the total amount of energy used by that building on an annual basis equals the amount of renewable energy created right on site. Solar is required, storage is optional, but batteries add significant points to that ZNE rating system. Smart programmable batteries get double the credits of standard batteries here. Let's go to the next slide. ZNE. Actually, I just talked about that, didn't I? Let's go to the next slide to talk about leadership in energy and efficient design, LEEDs. This is a green build standard certification. It's very similar to the others. Solar and energy storage are categories to add points in the program. Platinum Plus, Solar Plus Storage is a new designation. Let's go to the next slide, which shows a little bit about key takeaways, but we're not done. I just want to show that designing with energy in mind, moving forward, if we think ahead, whether it's a custom home, a multi-dwelling unit, or a whole community, we can future-proof homes that are built today. We need to be thinking ahead because codes and compliance are constantly evolving. Many of us are living in older homes. We may not even know if the home is up to date or legal in today's standards and requirements. But also, designing with smart energy and energy automation in mind brings you that key brand differentiation. You can take yourself right out of the mix and make yourself stand out with smart energy and energy automation. It's a huge value add for homeowners. Let's go to applications of energy storage. And then the next slide says, number one, solar optimized backup power. So we're going to talk now about the different ways we apply energy storage. The first is we provide power for essential loads in the event of a grid outage, whether it's planned or unplanned. We allow solar to continue working during that grid outage. And if you add solar plus storage, you have a perpetual backup. So your sun is creating that power during the day and you're using it up during those peak times and overnight when you don't have sun. With an uninterruptible power source, you can protect sensitive electronics and not worry about those security systems, lighting control, etc. Let's go to the next slide that shows solar energy management. Solar energy management allows us to use solar energy day and night. It allows us to work with time of use management. And here we're talking about primarily areas where energy is super expensive during those peak times, like in California, Utah, Colorado. So they're paying like 40% more during those peak times for energy than they would be during maybe the middle of the night. So if you have a battery, you don't have to have solar. You can take that energy, buy it at the least expensive time, fill up that battery, and use that less expensive clean energy in your home. That's called time of use management. Solar shifting is another application. That means the power you generate during the day, it's going to be stored to be used later. In addition, you can take that energy, stored energy in that battery, and you can connect it to your home automation systems. So let's say lighting control, shade systems, temperature control, garages, security. You can add those loads, and whether it's an outage or you're just using it all the time, it allows you to use that clean produced and then clean energy for those sensitive electronics. Feed-in tariff capability, we don't have that here, so we're going to talk about powering automated home energy, I can't even talk, powering automated home energy management with clean energy. Let's go to the next slide. Here are two examples. The first we're going to talk about is solar self-consumption and then time of use. So this slide shows example of full solar self-consumption. Let's look at that color key down at the bottom. The SOC is that purple line. That means that's the state of charge. So you can see that you have produced that much energy all the way to the top. And then consumption is that blue part. So you can see it, the little peaks and valleys, and then maybe some big peaks during the middle of the day. Maybe that's your air conditioning or something. And then the PV production, which is that yellow, beautiful hill of solar production. You're producing that clean power during the middle of the day. Discharge. This is super interesting because that red part of the chart that you're seeing with tiny little peaks and valleys, you're seeing that during the production during the middle of the day, you're not using so much solar, but during the nighttime when you have that peak use, that's when your battery's working hard. Let's go to the next slide to show us an example of time of use. Again, that purple line at the top, that is state of charge. So you can see it's charged all the way up to the top. And then the consumption, you can see all those little peaks. That's the blue peaks and valleys during the day. And then we've got the PV, that beautiful yellow hill of solar production during the middle of the day. And discharge is in red. Now, let's look at that right side, that big, let's see, that must be around, I don't know, 10, 11 o'clock at night. What do you guys think that could be, that little blip up there? It's a spike. I'm thinking it's about the same as during the day. I'm wondering if it's like air conditioning or heating or something like that.
Well,
Let's go to
the cooking.
It could be, but are you cooking at like 11 o'clock? Maybe it's maybe it's later. Maybe it's a midnight snack, Jeff. I think it is. Let's go to the next slide. Energy automation. About smart weather forecasting. So,
hey, Dad, you blanked out for a second there. Can you start at energy automation, please?
Sure. The third application is energy automation. So we're going to be talking about how we're using that battery backup to connect to a smart weather app. to forecast that bad weather outage, or let's say it can actually see a storm coming, so it fills up your battery. It can actually connect to your thermostat and pre-cool the home. It can connect to your automated shades, bringing them down to continue to cool it. I'm talking in Florida. It would be different elsewhere. It can manage other devices. It can pair with controllable breakers, like smart breakers, so you can add and take away loads depending on what you want. Let's say, you know what, right now my refrigerator is my highest priority. I don't want any of that food going bad. And my TV and my lights in all of the rooms except the family room are not a real big problem. So I'm managing that energy. The energy is in my battery. I've either produced it or I've purchased it at the best time. And now I can use it for energy automation, automating my decisions. We can actually program it, or the homeowner can choose it on an app or right on that battery device. Let's go to the next slide, which is smart grid of the future. So designing homes now with smart energy management in mind helps us plan for the smart grid of the future, where we talked about being decentralized, digitized, decarbonized, not using any coal anymore. It increases the flexibility of the existing antiquated grid. It provides controllable energy generation and consumption for utilities. It provides grid resiliency in the event of outages. It reduces stress on the grid. And there's other monetizable grid services. We can actually, a developer could purchase a bunch of these batteries for a community and sell that excess power back to the utility. It's helping the utility, it's helping the homeowner reduce their costs, and the developer actually creates a supply of money for their future. The next slide talks about selecting an energy storage system. So we're going to talk about what things are important in selecting an energy storage system. The next slide is why chemistry matters. That's the first point that we're going to be talking about. Safety. Lead acid batteries contain lead plates. These lead plates degrade as the batteries equalize, and gunk builds up, requiring maintenance, and it's a potential fire hazard, and it can off-gas toxic fumes. Those are lead acid batteries. Lithium chemistries, whether it's nickel, manganese, cobalt, lithium, cobalt, oxygen, or nickel, cobalt, aluminum oxide, these batteries are designed to really take a car 250 miles on a single charge, fast charge. A lithium iron phosphate, it is a safer chemistry. It has zero thermal runaway. It's safe and cobalt free. Jeff, can you start that video? Are you able to do that? This video shows a battery safety test. And that
the video is running now.
Okay, I'm seeing it now. Good. So this is a lithium iron phosphate battery. It's showing that even though it's been punctured, it has no thermal runaway. It's not catching on fire. You see a little foam. It's up to 125 degrees, but it's not creating a problem. It's not going to explode. Now, this is important because these batteries are in people's homes. You might put it in your garage. You might put it in your basement. Could a puncture happen? It could possibly. Let's say you drive into the battery. That would be ridiculous, but I have a teenage kid. I don't know if anybody else does, but things happen, right? Now we're seeing that the test is moving over to a different kind of lithium chemistry, like a nickel, manganese, cobalt type battery. And in this next part, we're going to see, has it stopped?
No, it blew up. Lots of fire. Jessica, you still there?
Yeah.
You're muted, Jessica.
All right. Hello. So I'm gonna take in from here. So what we're seeing here is another type of chemistry that is common in energy storage solutions called nickel manganese cobalt, or NMC. And as you can see here by this battery test, as soon as that battery cell was punctured, it immediately caught fire, right? It put off what we call thermal runaway. And chemistry, this is kind of what Deb was talking about. Chemistry is really important, again, because these are going in people's home. You certainly don't want this situation here that we just saw with the fire explosion to occur in someone's home. Now, keep in mind, it's not just, this test isn't just representing when a battery is punctured. It is meant to represent worst case scenario. So like Deb said, if someone backs into it, but this also represents what would happen if short circuit were to happen in a battery. So keep that in mind too, as sometimes cells tend to get to the end of their lifetimes, they could short circuit, and you certainly don't want this to be the outcome. So safety and chemistry, very, very important when you're talking about putting something in people's homes. And keep in mind too, typically when you're talking about energy storage systems, there's on average about 600 to 1,000 of these individual cells in each battery storage system. So lots and lots of individual cells, which can really potentially cause some problems for homeowners. Now, the purpose here is not to scare our homeowners. We certainly don't want to make them fearful, but we do just want to educate them that the more safe chemistry is certainly going to be that first test that we saw with the lithium iron phosphate chemistry.
Thank
Let me
you.
interrupt you right there,
Is
Jessica.
lithium ion. Yes, sir.
Do we have Deb back?
I am back. Yeah.
Hi, Deb. Okay, take it from there. I'm sorry to chime in.
Thank you so much.
We're still on the
Actually,
chemistry matters slide. We just played the video.
right. Thank you. We can move on to longevity, the next slide, if you don't mind.
Okay.
So this is the second part of why chemistry matters. We talked about safety. We saw the slide. And thank you, Jessica, for jumping in. Longevity is the other important part. So some batteries we have, like on the left, you see this nickel manganese cobalt battery has a shorter battery life than the one we see up here, way at the top, the lithium iron phosphate battery and other batteries that last maybe 5 times longer. So longevity in a battery chemistry is also very important to consider. Let's go to the next slide. The other important part is being eco-friendly. It's important to find out if your battery is cobalt-free and is it 100% recyclable. Can those batteries be completely taken out and recycled? Let's go to the next slide. We're going to talk a little bit about the technical details of an energy storage system. Alternating current connections can come from the top or back of the enclosure. Some batteries require external components, so you have to be aware of that. If it's going to need an external component, is there room in that space, in the garage, the basement, an equipment room, or a living room? An automatic transfer switch, the important thing to keep in mind is the transfer time, taking it from grid energy into the battery energy, switching over. An inverter is what converts the AC current from a solar system to DC, direct current, that we use in the house. The SPRI, up to the right, it says SPRI microcontroller. That's the brains of the system. And then below that, you can see battery modules. That's where the smaller units of energy, typically 2.5 or 2 kilowatts of power or 1.5 kilowatt hours. Some systems scale all the way up to 30 kilowatt hours. Let's go to the next slide. Showing key factors for choosing a system. The first is, I'm sorry if you can, I hope you can hear me. There's a guy outside mowing. Key factors for choosing a system. The application, what's the goal? Is your goal solar self-consumption? Are you going to be creating and using the power? Is it going to be time of use? Are you going to purchase that power from the grid at a very inexpensive time and use it when you want it? Or are you using the system as a power backup for outages? The form factor is another consideration. How big is this? How heavy is it? Is it all in one? Is the system size going to work in your home? Does it work with every solar system? And does it integrate with home automation? Let's go to the next slide that says designing with energy storage. And then the next slide after that, the basics of designing solar and storage. You can see the energy storage battery sits, that's in the middle. It sits behind the meter. So you've got all the way to the left, you've got grid power feeding into that main panel. That main panel powers non-essential loads, and that main panel can power that battery. So you can actually get grid power to power your battery. There's a need to establish a protected loads panel, or PLP, for essential loads. An essential load is whatever your homeowner wants it to be. So for me, it's probably going to be my fridge. I'm Italian. I want to protect that food. But maybe for somebody else, it's lighting, or maybe it's a mini split AC or something like that. So there's we would never want to recommend using medical or life-saving equipment on that subpanel because of the automatic transfer switch. It takes a little bit of time. Maybe it's only 10 milliseconds. Maybe it's only just a few milliseconds, but we don't want to put that kind of life-saving oxygen load or something like that on that subpanel. But we would recommend you use lighting, small HVAC, water purifiers, refrigerators, outlets, and things like that. If it comes to designing more larger loads, there may need to be multiple protected load panels, and we may need to increase the batteries, maybe add some batteries, or use a larger storage system. And there are more advanced systems out there that require like a home integrator, somebody to include those. You take all that energy and use it in your home automation. So that might require a home integrator, like Boca Tech. Let's go to the next slide. We're going to talk about output versus capacity. To understand the impact of the loads on the battery, those refrigerators. Yeah? Am I good?
We're losing you again, Deb. Maybe we should switch over.
Okay. Can you hear me better now?
All right, go ahead. Let's see if it works.
Okay.
Yes.
We're gonna review output power versus capacity. Like a car engine that provides power to the car, the battery inverter provides power. This output power for a battery is measured in watts. So the capacity for a battery to store energy is measured in watt hours. So this is output power versus capacity. So the gas tank is the capacity of a car. It's how much gas it can store. With other factors, it determines how far your car can go. Likewise, the battery capacity is how much energy it can store in kilowatt hours. So that's why an energy storage battery capacity is measured in kilowatt hours. So let's say we have 20 kilowatt hours of power, fully stored battery. We can choose to use it on maybe 8 hours is our refrigerator, and we have 2 hours of television and 5 hours of my really efficient LEDs or something like that. But I can make those choices as a homeowner. So the engine gets the car rolling. The gas tank determines how long the car can go. And if you were in a car and changing driving habits, like hypermiling like I do in my Prius, that'll determine how many miles per gallon the car gets, just like the consumption rate of a battery, solar battery or storage battery. Let's go to the next slide to show sizing do's and don'ts. Determining how much capacity or battery power required can easily be calculated by a simple math exercise. So you can see that where it says load examples, you have refrigerator, kitchen lights, garage door, all the way down to outlets and things like that. A simple look at a spec sheet for those items shows you the watts per hour that it uses. You figure out the loads and size the system to support those loads. We would not, for example, determine the size of a system based on somebody's budget, and we would not buy this or determine it by the square footage of a house. You have to use the information about the loads that they want to protect and that they want to use their battery for. That's the only way to determine size. Let's go to the next slide that shows physical design considerations. There's a lot to consider. There's a lot of different types of batteries out there. Can it be used indoor or outdoor? Is it an all-in-one solution with a small footprint, or are you going to need to add some components requiring floor space or wall space? What's the elevation? It actually is a big difference if you're in Colorado and have to change with that elevation. If you're in the mountains or if you're at sea level, it actually changes your design. Is there humidity? Let's say you're in Florida. We are. Putting a unit in the garage might not be the best choice because it's going to need to be a conditioned space. It needs to be free of dust, corrosive, and explosive gases, and vibration. Can't be right next to a railroad or continually moving. And it has to be a flat surface, and it has to be load bearing because you've got pretty heavy batteries. Let's go to the next slide to show other installation considerations. Hold on a second. Okay, so other installation considerations. You need to understand your customer's goals and expectations. It needs to be compliant with NFPA, that's fire requirements, national energy requirements, local building codes, wiring code, spacing between units, clearance for ventilation, and easy access for the installation team. Let's go to the next slide. So for things to remember when designing, you really want to make sure you understand, are your clients using this for time of use? Are they backing it up? Are they really hoping to be self-consumption based, producing and using that energy that they're producing? We're going to size to the application and the loads, not to their budget and not to the size of their home. Devices with large draws like pool pumps and large AC systems will impact the battery life, and it will reduce greatly the length of time that battery can power those devices. Where is the battery going to be placed? Are you going to need a crane? Does it have to be put into the house before the stairs are built? An all-in-one solution might offer a smaller footprint if that's something that you're looking for. Let's go to the next slide, which is conclusion. And then the next slide, we're going to talk a little bit about the smart home of the future. Energy storage is a really important part of building cleaner, healthier living, but it's only part of building that. It's only a building block. You also need to consider insulation, high performance windows, thermal walls, heat exchange venting, maybe energy efficient appliances, of course, smart appliances, high efficiency heat pumps, for example, maybe heat pump water heating, LED lights for sure, go with LED for sure, variable speed smart pool pumps, that can actually really help. Self-generation of power. Are you going to, in your next community plan or multi-dwelling unit plan, are you going to consider rooftop solar? Smart energy management. That's really what we've been talking about today. Smart energy storage, a Wi-Fi learning thermostat, home automation that's going to help you pre-cool your home for an outage, for example. and whole home energy management. So the homeowner is in charge of that clean energy that they're producing and storing. And we're going to also, maybe you'll include EV, electric vehicle charging stations. I actually plug mine in at home. I know that Jeff has a plug at his office for his car. And then virtual power plants where possible. So you could create a hive of energy production and storage, selling it back to the grid, monetizing that, helping the residents reduce their costs, or creating a community of batteries. Let's go to the next slide. We're just going to show one example of a custom home. We might have an EV charging system, a wine cellar. Imagine if your homeowner has a wine cellar, they've invested a lot. They want something like a battery backup so that they can keep that humidity and temperature controlled. Maybe they have luxury, really great AV equipment. I know Jeff and his team sell speaker systems, beautiful televisions, distributed audio, video. These require clean energy, and not having that clean energy is going to affect the lifespan. Solar plus energy storage, and self-consumption, energy security, energy automation. You could even plan for smart weather forecasting by adding some software, and it connects to a weather app so that if there is an outage coming, your battery is full, you can pre-cool your home, your shades are down, that type of thing. Dynamic load management. This is really an important part of smart energy management, where the homeowner is in charge of adding or subtracting a load depending on what they need. Eco-friendly intelligence, and differentiating the architect, builder, or developer of the community. So you're creating a name for your brand. Not creating, maybe adding some value. Let's go to the next slide where we show an example of a community that we've been talking about. The first we're going to be talking about is Mandalay Homes in Prescott, Arizona. This was a real innovation for the U.S. electricity grid. It's the largest carbon neutral master planned community, 2,900 homes. This community uses solar plus storage, and it's the first significant residential energy storage system based community. It helps homeowners because it provides them with extremely low utility bills and backup power. And it's made a name for Mandalay Homes as a green builder. In addition, it provides demand management for the local utility. It reduces the utility rate, and it creates the scene for a virtual power plant. Let's go to the next slide, which shows an apartment complex. This was a planned community in Utah called Solely Lofts. This type of community is a virtual power plant. It's utility controlled. So they have intelligent energy storage batteries in each of the apartments. It's super unique because what they've done is they've made a partnership with the builder, developer, residents, and the utility. So it's actually helping the utility to provide for this new demand of this large apartment complex. Demand management control means the utility is actually able to help when that peak demand comes, they're able to draw on the excess power that Solely Lofts is creating. Some technical details about that is 5 megawatts of solar and 12.6 megawatt hours of energy storage are being produced there. The virtual power plant is 12.6 megawatt hours total, managed by the utility, Rocky Mountain Power. Here there are 22 solar powered buildings, including 600 apartments, a clubhouse, and 150 electric vehicle chargers. This is a really great example. I love this one. Let's go to the next slide. this is the end of this CEU portion, and I wanted to open it up for questions, if anybody has some questions.
Wow, that was a that's a great presentation. Thank you very much for that, and I love the tag team there going back and forth. I have a couple questions here. We've only got about, I guess, about 10 minutes left. Um, so if I were trying to plan out something like this for both new construction, single family home, or a retrofit, two different questions here.
Yeah.
Who is the go-to person for that? You know, I mean, clearly like an electrician isn't going to be clued into this, right? They read blueprints and install to a plan. So is this something
That's right.
you would go to an architect for, or how would you do that?
So if you're a homeowner, you would find somebody like you, Jeff, who knows about energy storage and management and can combine it with intelligent appliances, smart home systems, AV systems, distributed audio video, maybe AC, smart thermostats. So they would look for somebody called an integrator. And that person would have an electrician who is certified to do this kind of installation, make sure that it's, seamless between the production of energy, the storage of energy, and that energy management and use of that clean energy. So we do have a couple more slides if you want to keep going, but do you have did you have anything to say, Jessica, on that?
Hit it on the head. So I what we see a lot is we see integrators, we'll take Boca as an example, working with local architects and designers to map this out. They are a lot of times like folks like Jeff and his team and others out there, integrators, they're technology experts. They're wonderful at being able to bring energy storage into the fold of the home and work alongside other things in the home that have an impact on energy. Things like lighting, shading, like she mentioned, HVAC, electric vehicles, all of those things. So by partnering architects and designers, partnering them up with integrators, you're able to together design the system, get it on the plan set, and really provide a full comprehensive solution, a smart energy solution, a healthy home solution, a high-tech solution for your homeowners.
I want to point out that batteries can be as small as, maybe 10 kilowatt hours, which would be for maybe just a few things that you would power, up to maybe 30 and more. And there's more coming. 30 kilowatt hours is a lot of power for a home. In addition, you can sometimes stack those batteries or add a battery in a subpanel and another battery in the subpanel to create a system that works for your home. Maybe you're backing up your AV system on one, maybe you're backing up a security system, lighting and shades and thermostat, things like that on another. And maybe you've got your network system on yet another. But it really depends on what loads, again, that those homeowners are really looking to protect or back up.
Yeah, I mean, from personal experience, because when we built this building, we put 16 kW of PV panels on the roof, and I've got a 20 kW power plant with only 8 kW of storage though, and that's kind of a weak point. It was based on the battery technology available 6 years ago, and we're swapping that out soon enough. But I think the most important thing would be to divide your loads from the get-go, or if it's a
Good
retrofit,
point.
then do it then. And it's everything you mentioned, air conditioning loads and things like that, mini splits, air conditioners, washer, dryers, those kinds of things need to be kept different so that when you go to load shed, you can say, hey, I can not do laundry, kill those, but I want the TV to run, or I want the air conditioner to run. I want the refrigerator. I love that. You're Italian. You like to eat. You got to have that fridge,
It's important. That's essential.
You gotta, right. I also saw Stonin when they had a demo when we were allowed to, get together in big groups. Um, you talked about predictively analyzing what's happening in the weather and preparing your system far in advance.
Yeah.
In other words, let's make sure if it's during the middle of the day or whatever, that battery is full at the time of the outage, and that your energy consumption load shed is prepared so that you have the longest run time in the event that something did happen during inclement weather. I thought that was really intelligent. I don't know if you have anything to add to that.
So I think too, so not only, so preparing the home, let's take your weather example and pull that a little further. So not only when a battery is paired with the home automation system, that technology, not only is we're predicting the, automation platforms looking at the weather, charging up your energy storage system to make sure you're fully prepared, but it's also doing other things in the home to get it ready. For example, weather's coming. My goodness, it's the middle of the summer. It's hot as heck down there. We want to lower the shades and we want to lower the HVAC to try to pre-cool that home, get it nice and comfortable ahead of that outage so that when the power outage happens, you're not using your battery power on HVAC anymore because you've already done proper measures to prepare the home ahead of time. And now you can use that battery power on other essential things in your home, your fridges, your freezers, your lighting, your wine cellars, whatever is most important to the homeowner. So it's really cool to bring these technologies together and have them work together to seamlessly provide and prepare your homeowners no matter what comes their way. And also, I would say the coolest thing, Jeff, is being able to give them the dynamic flexibility with energy automation. Every power outage is totally different. Today's power outage, it might be really important to you to keep all your lights on. Maybe it's just a really short outage so you can power your lights and everything else in your home. But maybe the outage a week from now, maybe that's a much longer outage, and maybe you need to stretch the life of that battery. You can actually turn things on and off at that breaker level with energy automation, with the home technology, Jeff, that you offer every day. Really give your homeowners flexibility and power different things depending on the outage and depending on what's important to them at that time. Really, really powerful.
So another quick question or two, because we're about one or 2 minutes over. You mentioned a 26% tax credit going to 22, I believe you said next year. What do you have to do to qualify for something like that? What does that actually mean in terms of if I'm planning ahead, trying to use that as an incentive?
Yeah, so I actually have a slide at the end that shows where you can go for some more information about that. It's the Department of Energy, energy.org. And that's where you can find some information. Let's see, is that the only place? That would be a great place to start. You have to install Solar Plus, the storage, if you're going to add storage. It can be just used for solar, but if you want to add storage, you have to have Solar Plus storage to qualify for that. It's a federal tax credit.
And can that be done like retroactively, or like if you didn't take advantage and know about it, like in my case, or is that something like only for a new build?
That's a really good question. I think it can be done retroactively. Yeah.
It can. So as long as you're adding new solar, so you would have to expand your solar system, Jeff, or whoever out there, if you have an existing solar, as long as you expand that solar, it would have to be new solar panels added with the addition of storage, then you would be able to receive that tax credit. It's a great question.
One final question, then we'll wrap up here. I have seen tests with batteries blowing up by, take a cell phone, hit it with a hammer with a nail kind of a thing. It is
terrifying,
mind-boggling how quickly and how ferociously the heat climbs and can create a bomb. What is your thought on parking an electric car in a garage in a house? Are we at any danger of doing that?
Jeff, you're the one who's driving an electric car, man.
Now you know where the question comes from.
So personally, I have a plug-in hybrid. So I have gas and electric in my car. I park it inside my garage. Is there a danger? It's potential danger, sure, but I'm mitigating my risks. So I take that risk as part of my home ownership, and I'm pretty careful. But I mean, people do it. We are doing it every day.
Yeah, I mean, for me, if someone asks me that question, I'm not concerned about it. I know that it's sealed. I actually feel more comfortable in the garage where the car is not hot. It's not sitting out
Yeah,
baking in the
that's a
sun.
good point.
I do hear my electric vehicle's fan regulate the temperature of the battery on and off automatically when it's say outside in a hot sunny day. You walk by and someone says, "You left your car running." I'm like, "No, I didn't." But anyway, I figured some people might have that question because it's scary, it's new, it's unknown. And I've
Very
heard
true.
other people tell me that. It's like, "Oh, well, I'm never going to park inside. It'll blow up my house." Like, I don't think so, you know.
Yeah, yeah, it's a mitigated risk. I mean, you've got to with a gas engine, it's very, very similar. You've got a potential
Right.
explosion there. It's gas, but we mitigate those risks. Like you said, it's a sealed system, and it's not out in the sun, so that's good. It's not being punctured, so that's good too. So
Right. Right.
should we send those additional resources maybe with the AIA certificate, and that way they
Yeah,
can
let's
follow
do
up?
that.
Okay.
I feel like we need to talk more on this, but we're out of time. I mean, this is
I know.
I could do another hour. I mean, this is really good. Thank you so much for all your prep work.
Thank you.
Fascinating. Just
It
fascinating.
is my favorite subject. I could talk about it for the next 10 hours. Thank you so much for your time today.